Another way that we can make esters is through the process of esterification. In this case, we use a carboxylic acid and an alcohol under acidic catalysis. Let me show you how that works. Now again, we've got our same pattern here where the Y group ends up being replaced with some X group. And you can see this is going to be an acidic mechanism because we have an H+. And here's an example of it. First of all, let's see if we can identify the same groups in the pattern. And that would be this one. This is going to end up being the Y group. This business here ends up being the X group, that's XH. And over here, here's your X group. And over here, this would be YH, so HOH, H2O. Alright, let's take a look at how the mechanism goes. This is a classic positive mechanism. First step, the H+ attacks the C double bond O. Leaves a positive charge on the C. Alcohol comes in and attacks at the C+. Now in this next step, what happens is that the proton gets transferred. And one thing we've noticed, and we've noticed this in the other mechanisms that we've looked at, is that in a proton transfer step, the H+ always ends up getting transferred to what is going to be the leaving group. Now looking at the overall pattern, you can see that the Y group here is the leaving group in each instance. So whatever was originally attached to the C double bond O, in this case the Y group, is what will end up taking the transferred proton. And that's what I'm going to show here. So there's the Y group there. And it will take the proton off the group that ended up attacking. And that's what we're going to end up with. Now you might say, well, we've got two OHs here, why does it matter which one it attacks? Well, it really doesn't, I guess, but there will be other instances where we will not have the same group here, and you'll have a choice. And you'll always have to choose the Y group anyway, so may as well start doing that now. And that's what we're looking at. We're going to use the Y group to take the transferred proton. In the last step, we can reform the double bond to be oxygen and kick out the leaving group. And that is the mechanism for esterification. Again, it follows the classic positive mechanism, one we'll see a lot of in the future as well.